Alright, so this is video reassessment 5 for assessment 5. I'm going to be doing problem 22 in chapter 5, section 7. It's going to be dealing with circular motion and net forces, sometimes including gravitational, but in this video we will not be doing that. Problem 22 gives us that an object is moving at a velocity of 23 meters per second. It's taking a curve right here. I have a nice little diagram. It's going around a curve, and the radius of that kissing circle is 4 meters, and the magnitude of momentum is 78 kilograms per meters per second. Alright, so we're actually going to be looking for the instantaneous change of momentum with respect to time. This actually will equal our net force, considering that it isn't, anywhere in the z direction. There's not really a change in gravity for that. We're really just dealing with the force going around the curve, directed towards the center of that. So you can rewrite it as the instantaneous momentum with respect to time as the parallel and perpendicular forces. The perpendicular is going to be, like I said, the one that's pulling in towards the center of the circle. And we're also given that the speed is constant. Therefore, there is no change here, so that's 0. So it's actually just going to be the force that's pulling here in towards the center. And that can be rewritten as mass times velocity squared divided by the radius of the kissing circle. And if you rewrite that, you can pull out the mv and just leave it as v over r. And as we know with the momentum principle, that momentum is mass times velocity. Therefore, your instantaneous change of momentum with respect to time will be equal to momentum times velocity divided by the radius. And we were already given most of those, so the momentum 78 times the velocity 23 divided by the radius 4, and that'll give us 448.5 kilograms per meters per second squared. And as I already said, the net force is actually equal to the instantaneous change of momentum. And we're given also that parallel speed is constant, and we've just figured out that the perpendicular force is 448.5. Therefore, the net force is also going to be equivalent to 448.5.